Hello. So in my last video, I did this circuit, which is to convert 9 volts down to 5 volts, and I'll just do a quick demo of that now. Put it on that, and yeah. So wrong way. So across here, you have 5 volts, even though it's 9 volts coming in here. But then I realised obviously that if I add more load onto this, like other than just this resistor, it will use more power, and the value of this resistor starts to matter. So this video is just going to be an experiment of that, and how many LEDs I could put on here, and observe how it changes the current. So I'm just going to disconnect this for now because right, that's how I'm going to do this. So we want to observe the current. So what I'm going to do is going to grab another wire here, and I got these crocodile clips because I don't actually have crocodile clips for these, and just getting actual crocodile clips was cheaper. So the idea was to just do that, and I can use that to tie into these. I want that one there, and then the back. So this means I don't have to disconnect it and stuff like that. I can just add things, and we can see the change as we go along. Right, so I need to change this to milliamps. Right, let's plug that in and see if we can get a... Right, so... Is that... Okay, so let's read it on here for the moment. 20... I don't know what that is, to be honest. Is that milliamps? So that would be 4.6 something amps. Okay. Now, as I add LEDs to this, I would expect to see that to go down. So let me just start plugging some in. Well, I might have to rewire this a little bit. So let's put green LEDs in there because they use a lot of power. If I can get them. Right, so how do we want to do this? So we want this no. I don't know what value resistor that is. I think it's 1K. Yeah, it's 1K. Well, that'll be okay. We can just turn it around like this, and we'll just put jumpers along here to add more LEDs to it. So let's put that over there. So that's gone from like 4 something to 3.3. So let's add in another LED. I need let's get some little jumpers here. This might be a little easier. Tweezers. Right. And this one. Can't see it because the LED is really bright. Okay, so it's really bright. Okay, get in there. Right, that's 3.4 still. But obviously the LEDs aren't as bright, which is nice. Okay, let's add in some more bits. We'll set this up first this time because it's a little easier like that. Right, another LED. So on 3.3, basically 3.5. Still 3.5. I was expecting this to drop a lot quicker, to be honest, because that's how much power this is drawing. You'd think when you're drawing more power it would reflect that. Maybe I just haven't hit that threshold yet. Okay. Shove this one in. We're still on 3.5. Okay, this is holding up very well. A lot better than I thought it would. Okay. But I'm aware these LEDs, you know, while they're using a lot of power compared to other colours of LEDs, they're still not using much in themselves. So that it might take a while before we actually see a change here. I might speed this video up at this point. It's still... It all feels dandy. Right, what I'm going to do is I'm going to swap out this 1K resistor here for another one. Right, something a lot lower. Like, I say 220. It's going to blind me, but... Put that there. Okay. So we're going to swap this one out. Put this one in. Now it's drawing more there. Those LEDs don't actually seem any brighter, but they're all connected in series here, so... Sorry, in parallel to the same resistor. So that's probably not helping it. Maybe we'd see a difference if I use a resistor for each individual one. Maybe. Should I try that? What do you think? Just realised that wasn't in properly. Yeah, so this doesn't seem to actually be affecting it in the way I thought it would. So what I'm going to do is I'm going to swap this round to this rail and get rid of all these little bits here. Keep going. And what we'll do is go back to the resistors. Yeah, these are the... So they don't have many good values here. Not of these small ones anyway. Well, I have loads of resistors for these LEDs, but haven't had much reason to use them yet, so they're not even unpacked. So, right, we'll just start doing these. So these are all connected to the same power, but they're all going to have their own individual resistors. Right, so that's on 5.4. Oh, 6. Okay, here we go. Now it's drawing more power. 6.4. 6.5. Still, I'm not seeing a massive drop or a massive... Like, what I'd expect to see is that when you're using more power, they'd all get dimmer because there isn't the power on here to handle it. But that's intriguing. I think I would need a lot more LEDs to actually notice the difference here. I guess you've got 4 volts of spare power here because it's getting rid. This is what it's getting rid of 4 here. But if you're using power, it's going to be getting rid of less. So maybe that's what's happening here because there's a lot of power spare. Yeah, I don't know. If anyone can explain what I'm doing wrong here, or I mean, we're definitely using more power as we add LEDs now. But how would I work out how far I could go with this? And I'll have to look up what I'm actually looking at here because 20. 20, I guess that means 20 milliamps. That means 200 milliamps, but I don't know. It's early in the morning. But yeah, we're definitely seeing a difference now. I just wish I could measure this in a way that it would make sense. Oh, hello. Okay, it doesn't like it when you try and measure that far. Pulls too much power out. But yeah, okay, so we're seeing a difference. Is that 6 amps, 6 milliamps? I don't know. But yeah, this was just a quick test. Wasn't sure what I'd expect. I mean, I had one expectation, and that expectation has let me down a bit. I was expecting to lose power after a few LEDs, but obviously not. I was expecting to have to lower the resistance here to get it to allow more power through, but obviously not. But yeah, thanks for watching, and see you later.